Hey everyone, today we are going to solve the Daily LeetCode challenge of 7th March 2024, and the problem statement is middle of the link list. So let us first understand the problem statement. So according to the problem, we have been given a link list and we have to find the middle of the link list. Okay, now let us see what is the middle of the link list. Okay, so in this problem, we are going to have two of the cases. First, when we have a link list of odd length. So here you can see that what is the length of the link list? It's 5, right? So this is a link list of odd length. And the second case is when we have a link list of even length. So here you can see that what is the length of the link list? It's 6. So in the first example, let's see which one is the middle of the link list. Okay. So here you can see that here we are having 2 nodes, and at this side as well we are having 2 nodes. So this one is the middle node, correct? So this is our middle node, fine. Now let's come to the second example. So here we are having these are the nodes, these are the nodes. So in the middle we are having 2 nodes instead of 1, right? In case of an even length. So which one are we going to return as the middle of the link list? So in the question, it has been mentioned that if there are 2 middle nodes, return the second middle node. So which one are we going to return? We are going to return this 4. Okay. Now I hope it's understood that what is going to be the middle of the link list in case of odd length and in case of even length. So let us see how are we going to solve this problem. So we will be discussing two approaches for solving this problem. Let us first now discuss the approach one. So in approach 1, what we are going to do is we are first going to find the length of the link list. Find length of link list. And after finding the length of the link list, what are we going to do? We are going to find the position of the middle element. What we are going to do? Find position of middle node. Now, after finding the position of the middle node, what we are going to do? Iterate up to position, and we are going to return that node, right? Return that node. Now, let's do a quick dry run to understand this approach, right? So, for this first example, let us take a pointer as current, which will initially point at the head of the link list. So, our current is pointing at 1. Okay. And let us take a variable len, which is initially 0. So len, we are using this len to find out the length of the link list. So what we'll say is that until our current is not null, we will keep on moving this current. Okay. So what we have said is while we have current, what we will do is we'll move this current. Moving current means we'll set current as the next of current, right? Current's next. And at the same time, we will say that length plus plus. Okay, we'll increment length as well. Fine. So we'll see, is our current null? So current is not null. So what we'll do, we'll move current to next element and we will increment the length. So length would be 1 because we have found out one node. Okay. Now we'll check, is current null? So current is not null. So what we'll do, we'll move to the next element. So we are now at 3 and we'll increment the length. So what would be the length now? The length would be 2. Now we'll check, is current null? So current is not null. So what we'll do, we will increment the pointer and we will increment the length as well. So the length will become 3. Now again we'll check, is current null? So current is not null. So what we'll do, we'll move the pointer forward and we will increment the length. So our length will become 4. Fine. Now again we'll check, is our current null? So current is not null. So what we'll do, we'll move the pointer and we'll increment the length. So our length will become 5. Now we'll check, is current null? So you can see that now current is pointing to null, right? So current is null, so we'll come out of this while loop. And the moment we'll come out of the while loop, you'll see that we have found out the length. What is the length? Length is nothing but 5. And how many nodes are we having in this link list? It's also 5. So now that we have got the length, we are done with the first step, that is finding the length of the link list. Now, can we find the position of the middle node? The answer is yes. So if you'll see that if we will do len by 2, right? So what we will get? It's 5 by 2, which is nothing but 2, correct? And that's the position of the link list, right? Because it's clear that, say for example, if we are having a link list of length n, okay, so where would be its middle node? It would be at n by 2, correct? So we are doing the same thing. We are finding out len by 2 to find out the position of the middle node. Now that we have got the position of the middle node, what we will do is we will set the current back to the head node, right? So current would be 1, and what we will do, we will say that while this 2, right? Let's say that this 2 is something as n. So n is 2. So what we'll do, we'll say while n, what we have to do is we have to move the current. Current is equal to currents next. So this is what we are going to do inside the while loop, and finally we'll return current. So let's do a dry run for this one. So initially our current is pointing at 1, and what is the value of n? N is now 2. So since n is not 0, what we'll do? We'll move current to the next node. So we have moved current here. So n got decremented to 1. Now n is not 0, so what we'll do? We'll move current. So current will now come here, and n will got decremented to 0. Now n is 0. So we will come out of this while loop. And what we are doing? We are returning current. And what is current? Current is nothing but 3. Current is storing 3 in it, right? So we will be returning this entire portion of the linked list. And you can clearly see that 3 is the middle node of the linked list still. Correct? So we have got the answer for the example 1. Let's do the same for example 2. Okay. Initially, our current will point at 1. And length would be 0. So since current is not null, what we'll do, we'll move current to next element and we will increment the length. So length would become 1. Now again, current is not null, so we'll move current to next element. So current will now point at 3 and we are going to increment the length. So the length would be 2. So since current is not null, what we'll do, we will move the current pointer. So current will point at 4 and the length will get incremented. So we will have length as 3. Now again, current is not null. So what we'll do, we'll move current to the next element and we will increment the length. So length will become 4. Now again, you can see that current is not null. So we'll move current to the next node and we will increment the length. So length would become 5. Now current is pointing at 6 and it's not null. So what we'll do, we'll move current and we will increment length. So it would become 6. Now you can see that current is pointing at null. So we will come out of this while loop. Now you can see that we have got the length, which is 6. Okay. Now what we have to do, we are done with the first step. We have to find the position of the middle node. So what would be the position of the middle node? It would be nothing but len by 2, which is what? Which is 6 by 2. That will give us 3. Okay. Now what we have to do, we have to set current back to head node. So what would be current in this case? So current would be now 1. And what is this n? N is 3. So initially n is 3. So n is not 0. So what we'll do, we'll move current to the next element. So current will come here. And n will get decremented to 2. Now we'll see that n is not 0. So what we'll do, we'll move current to next element. So current will point at 3. And n will get decremented to 1. Now n is again not 0. So what we'll do, we'll move current. So current will now point at 4. And n will get decremented to 0. Now you can see that n has become equal to 0. So we will come out of this while loop. And what we are doing, we are returning current. Now what do we have in current? We have this particular part, right? And you can clearly see that 4 is the middle of the linked list. How? Here you are having 2 nodes, here you are having 2 nodes. So in middle, we are having 2 nodes, that is 3 and 4. And in the question, it was mentioned that whenever you have 2 nodes as the middle node, in that case, return the later one, that is the second one, which is nothing but 4. So I hope now the approach 1 is clear to you all. So let's quickly code it. So let us first find the length of the linked list. So for that, we are going to write a function find length and we'll be passing the head in it, right? Now, once we have found out the length, what we have to do, we have to find the position of the middle node, correct? So what would be the position of the middle node? Let's say int position is equal to len by 2. Okay, now after finding the position, what we have to do, we have to iterate up to the middle node and return it, right? So what we will do, while let us take a node as current and it will initially point to head. So we will say that while position, what we have to do is we have to move this current. Current is equal to currents next. Fine. And we have to finally return current. Now let us quickly complete this find length function. So it is going to return us an integer, which would be the length. So here we are having this node head. Let's take a variable length as 0, and we are going to take this node current as head, and we'll say that while current is not null, what we have to do, we have to move the current pointer, and at the same time what we'll do, we will increment the length, and what we have to return is the length. Fine. Now let us quickly run this code. So it's giving us the correct answer. Let's submit it. So it got accepted. Now talking about the time complexity and space complexity. So you can note that if we are having total of n number of nodes, then the time complexity would be order of n. Why? Because say for example that this is the linked list given to us. Okay. So here what we are doing in the find length method, here we are completely iterating over the linked list, right? We are visiting each of the node of the linked list to find the length of the linked list. So the total time complexity would be order of n. Additionally, the space complexity is order of 1 because we are not using any extra space from our side. So this was the approach 1. Now let us discuss the approach 2 for this problem. Now what we are going to do in approach 2 is we are going to use two pointers, slow and fast. Initially, slow will point at the head of the linked list and fast will also point at the head of the linked list. Okay, and what we will do is we'll move slow by one step. Move slow by one step. And we will move this fast pointer by two step. Fast by two step. Okay. And until when are we going to do this? Until our fast is not null and the next of fast is not null. So what are we going to do? We are going to move our slow pointer by one step. So it means that slow will be next of slow. And we are going to move fast pointer by two steps. So it means fast will be fast next, next. Okay. And the moment we'll come off this while loop, we are going to return slow. Now, let's do a quick dry run for both the example to understand why are we doing this. Okay. So initially, our slow pointer is pointing at 1 and the fast pointer is also pointing at 1. Okay. Now we'll check is fast null? No. Is the next of fast null? No. So what are we going to do? We are going to move slow by one step. So slow will point at 2 and we are going to move fast by two steps. So fast will point at 3. Now again we'll check that fast is not null and the next of fast is also not null. So what we'll do, we'll move slow by one step. So slow will point at 3 and we'll move fast by two steps. So fast will point at 5. Now we'll check, is fast null? No. Is the next of fast null? So you can see that what is the next of fast? The next of fast is nothing but null. So we'll come out of this while loop. And what we are going to return? We are going to return slow. So where is slow? Slow is pointing at 3. And is 3 the middle of the linked list? So yes, 3 is the middle of the linked list. So using this approach, the moment fast becomes null or the next of fast becomes null, in that particular moment, your slow pointer is going to point at the middle of the linked list. Okay. So now let's do the same for the example 2 to understand this in a better way. So initially our slow is pointing at head. So this is slow. And fast is also pointing at head. So this is fast. Now what we are going to check? We are going to check, is fast null? No. Is the next of fast null? No. So what we'll do? We'll move slow by one step. So slow will point at 2. And we'll move fast by two steps. So fast will point at 3. Now again we are going to check, is fast null? No. Is the next of fast null? No. So what we'll do? We'll move slow by one step. And we'll move fast by two steps. So fast will point at 5. Now again we'll check, is fast null? No. Fast is not null. Fast is pointing at 5. Is the next of fast null? No. Next of fast is not null. So what we'll do, we'll move slow by one step and we will move fast by two steps. So fast will now point at null. Now again we are going to check, is fast null? So yes, fast is null. So what we'll do, we'll come out of this while loop and we are going to return slow. Now where is slow? Slow is pointing at this node 4. And is 4 the middle of the linked list? So the answer is yes. Why? Because this is an even length linked list, right? So it means we are going to get 2 middle nodes. So in the question, it's clearly mentioned that whenever we are having 2 middle nodes, we have to return the second one, that is 4. So this particular approach has been proved for both odd length as well as even length linked list. That is, whenever your fast pointer becomes null or the next of the fast becomes null, at that very moment, your slow pointer is going to point at the middle of the linked list. Okay, so let's quickly code this problem. So we will start on by creating two pointers, slow, which will initially point at head, and fast, which will also initially point at the head node. Okay, and what we have to do is we have to move slow and fast pointer until the fast exists and the next of fast exists. So what we will do, while fast and the next of fast, what we will have to do is we have to move the slow pointer by one step. That is, slow is equal to the next of slow. And we have to move fast pointer by two steps. It means that fast is equal to fast, next, correct? And what are we going to return? We are going to return slow, because the moment our fast will become null or the next of fast becomes null, at that very moment, the slow pointer is going to point at the middle of the linked list. So let's run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and space complexity. So the time complexity would be order of n. Why? Because we are completely iterating over all the n nodes. Okay. And the space complexity would be order of 1, because we are not going to use any extra space from our end. So that's all about today's daily LeetCode challenge. Thank you.